All right. So having covered the three concepts, now it's the time to go for the next three concepts, which are also plays a very important role in order to control your data integrity issues. The next one comes is check constraints. More or less, it's clearly indicating what check stands for, how the check can be used. Let's try to have a little information before we actually jump onto the examples. So the next one is check constraint. Let me put this way, check constraint. So the check constraint, the word itself is indicating you want to check before some data is getting into your database, some table or some column. You want to ensure a proper information is getting released into your database. So check constraint is used to limit the value range that can be placed in a column in simple. So using check constraint, we can specify the condition for a field which will be evolved at a time of entering the data. So while you are entering the data, we can just try to see whether it is a right record or not. And no doubt this check constraint can be applicable not only one column. Again, it can go up to multiple columns. So if you define the check constraint on a table, it can limit the values in a certain columns based on the values in the other rows. So that's the advantage of the check. But let's see practically in action, is this really a valid one? Is it really make sense to use the check in the real-time basis? That only we can check only by using a certain kind of examples now. So for that, I need to create a simple table now, again, the way we have created. So let me put some kind of a notes here so that you can refer anytime. Uh, Check constraint is basically, oh God, sorry, yeah. So let me go with a little kind of note so that you can refer. Check base, basically it checks what it will check. It, it checks the condition, whatever the condition might be. Like you put some condition on age, let's assume like only 18 plus are allowed to uh, join the organization maybe. Okay, so maybe you want to check the location should be in a Hyderabad, not anything else. So the units sold should be always greater than 10, or the salary should be, if you're not mentioning, if the salary should be always like greater than 10 lakh CTC, it should not be less than that. These are the few kind of check constraints which you can really imagine in the live environment. So let's see, again, if condition is true, what it will do is, then it will insert the data. Okay, what if the condition does not meet, then throw error, right? So that's what we wanted actually. We wanted to throw it an error because somebody is not giving the right information for us. So one important thing which you need to understand, that check allows null values. Check allows null values. This is a condition, guys. Whenever somebody asks you a question, especially in the interview, they will ask how many types of constraints are there. And more interestingly, they, in order to gauge your knowledge on the SQL, which is a standard language, they always try to see what is the difference between check and not null, what is the difference between not null and unique. They may ask the question any matter, but you need to keep in the mind how check works first, how unique works separately. Then if you start comparing, you can easily understand the reasons. So check allows null values, because check is only trying to check whether my condition is met or not. It doesn't know whether it's a null value or not. So in order to create a table, let me steal my own code, which I've written earlier. So this is my code, line of query. Here, I'll just try to create a table, not this time unique, this time it is check constraints. So let's say check. This is creating a check table. Instantly, let us create it. But here I have some other constraints. Let me remove everything and keep the table as simple as possible. Now, the very first column, we have an ID, which is an int type, EMP name, varchar 10, unique, unique. Let's not have anything in this. Okay, location is Dhaka. So basically, we have a three columns here, and let's see how we can implement a check condition this kind of scenarios. Okay, so for that, let's try to put a condition basically on ID. Okay, because I don't see any of the column which is very important, but slowly we'll try to put some other condition. Here, I want to see check the condition uh, before that, how you are going to write what kind of constraint it is. So we need to say, if you want to give the name, it's always good. But otherwise, if you skip also, your SQL Server system has going to create its own name, which is not so easy to read. So better to give your own shortcut name to remember easily. So constraint, and you want to give something called ch underscore id something, because it is, I'm giving it a constraint for the id, so try to give something name related to it. After that, what kind of constraint you want to give? So that is check, you want to check what check you want to do. For every id, I want to ensure that it is more than 100, sorry, greater than or equal to 100. So what is this constraint you are trying to put here? I don't want somebody to put ID number as 1, 2, 3 or something. It should be always greater than 100. It could be any number, but we need to ensure that it is going to be greater than 100. So let's create a quickly this table now. And I'm done with my check. We'll try to see at the end combination of all the constraints in a single table, how beautifully you can design a data table for ourselves. So let's try to refresh this. My table is created. I need to go for view and object explorer in order to see what is happening. So if I go to my database, I have constraints. I have tables here. Under the table, do have what happened? Let's go for a view and object explorer. So let me put this way. Got. So let me just quickly go to the database. Before that, constraint database, just refresh it. I should be seeing my new table, which is just created. That is check constraint. Now I'm more excited to see where exactly the check constraint is being created. Now here is my table. That's as usual because I've given the table name as check. If I go to the columns, ID is not null by default anyway because I've not put any constraints there. Employee name is null. This. So I'm still wondering where exactly this check is created, where I can say, okay, my table is now having a check. Let's go for a keys. I don't find anything because check is a constraint which you are going to see under the check. So CHID. So CHID is something which you have created for your table. So that's how you can see on your computer screen right now. So let's go for inserting some data into this in order to check the integrity of information. So what I'll do is I'll copy my own code again. I'll put the very first one. We have check constraint should be what? 100. Employee name should be there. There should be a location. I want to see if it is working or not. So for that, I'll put some 100 here to be very precise. Uh, Let me adjust my screen here. All right, now you can see there was a table which is created for the check condition, and my condition was clearly mentioned that it should be more than 100. So when I'm trying to use a check table, this is also a check table now because we are trying to insert a data. All right, so the very first one, if I see, is it going to work or not? That's my question. So when I'm trying to use 100, I'm trying to insert a data into this table. It's saying check table is not existing. Why? So that means maybe the table is not created or It's not saved the last one. Okay, the table is not created. So let's try to insert a row into this. One row is inserted. Now I want to keep handy this select statement because I can keep checking what exactly data is going to into my system. The select star from table, simple command, which shows you 100 Deepthi Hyderabad, which is a single life row, which you already inserted. So I've written very clearly it's working. All right. So let's go for the second one, where I want to check how far it works. If I say one, where first column is less than 100, right? So less than 100. So I'm just trying to write my own comments in order to understand what I'm doing here. So here the name, let's try to change it to something, Monty. Here, let's try to say jelly. Okay. So when I'm trying to run, what exactly you are going to expect from your output. So when I run it, it will clearly say that the insert statement confined with the check constraint, that is a check ID. So this is the advantage, guys. If you're trying to give your own name of your constraints, this is how it is going to spell out for you. So when you're trying to read your errors also, it would be very easy because it's the name given by yourself. So the conflict occurred because the database master, we are in the master, first of all. We are in the master table. We are not in the right database. So for that, let me select this one. Let me go here. Let me insert the data. Okay, so this is the actual error. Just ignore the previous one because we are not in the right database. Now you can see the conflict has occurred in the database called constraint DB. That is my constraint DB. This is my table, and it is telling you clearly the check constraint is imposed on this column. You cannot enter something like this. So let me go for the next one. I want to enter something called minus 80. Let's go for this. I'm running this again. Again, there is a problem. It is not taking, okay, negative numbers. Let's try to understand this way also. So as simple as that, you yourself put a condition. So I'm trying to cross check how far this is really working for me. So if I want to go for the next one, let's see, insert. If I say something called 1,000 value, okay, 1,000 value, which is obviously greater than your 100. Now if I go for location calls Chennai, and when I'm running this, no problem, it should work, right? But why it is not working? Because still I'm with minus. I removed this, just I inserted the row. Let me take the help of my select query. It's working. Okay, that's how simply we can see the data is being getting inserted into your database without any problems. So if I run all these four together, you should be seeing one as row completed, one row is completed, but there are the other two which is getting an error, right? So if I run this, you can see 3 rows here. So that means I ran two insert queries again. So that's why you can see 3 rows here. So that's how simply your check constraint is going to work, and it will keep checking whether it is uh, allowing you to the right information or so. At the same time, if you want to put this, let us also check one more condition here. I'm interested to see because as we understood, check condition constraints will also allows you nulls. Is that true? Let us see, because we want to prove every point so that when we are really working, you should not have any issue. Uh, Fortunately, it's allowing a null value here. Though the check is really working on your column, always ensuring it should be more than 100, but it is getting failed. Where it is failing, that is what I really interested in. It is failing at one condition that is called as, if you're not putting any information, it is taking something called null. So null is not a greater than 100 or less than 100, but still it is accepting because we have one golden rule here: check allows null values. So it doesn't matter how many columns you're going to put in null values. Even if I say all null values also, let's try to put everything null. Will it accept? Yes, it should, because here null, not in double quotes, because null is not a text. It is a keyword which we are trying to use, or constraint. So that's it. So here I try to use a three nulls cases here when I'm trying to run. It's still working. How come? So let's try to see, select query, all nulls. So it's working. This is also working, but we need to understand it's working. That means it's a good. No, it's not really good actually. When it is working, it doesn't mean that it's good, because when you have a constraint, you should ensure that it is a constraint. So that means, why can't we give one more constraint here that is not null, right? Once you say not null, you will be seeing the last one will not allow you to, is it not null? ID column, right? Select star from this table. Oh, sorry, my bad. First of all, you need to drop the table, check table. You need to drop this table because you are adding something constraint, right? So you need to run this again. And when you try to this insert a null values, it will definitely allow, it will definitely throw an error saying that it cannot be not null, because not null is working in this case. When I'm trying to run this one, my check constraint is working. When I'm running this one, check is still working and checking whether the ID column is more than 100 or not. When I'm running this, it's still working to check whether its number is more than 100 or not. So in reality, this is how the check is going to work. And we also understood which column is the best fit to have the check constraint. We can also have a check constraint basically on location, maybe like you want to say check if it is Hyderabad or not. For example, check, I want to say it should be Hyderabad. It's not true. In fact, if you try to see something like this is not really fair to provide a check constraint, something like location should be always Hyderabad, but just a hypothetical situation. So that's how the check is going to work in the real time, guys. So let me pointing. All right, let's assume that your table is already created without any constraints. Okay. And what if your boss asked, can you just create a constraint because we need to ensure this particular column should have always this so and so numbers. So what we can do is, let me drop a table first. Okay, let me drop a table, that is check table. Once you drop it, the table is dropped. Now, let me remove this entire stuff, what I've written here. Just remove that. I'm putting as a comment so that I can steal my own code. Now, if you see, the check table doesn't have any constraints here. It is as simple as a plain table. Now, assume that this table is created. Okay, the table is created now. I'm trying to insert some data here, 100. Okay, I'm trying to insert something data called 1000. Now, how we are going to alter this table in order to add or drop a constraint. Okay, already I dropped, so I cannot drop now, but let me show you the syntax here. Drop constraint, it's not too different because we already been seeing for the last three constraint how to drop. So I'll simply use the table that is check table, and you want to drop what? You want to drop a constraint, right? You want to drop what happened? Okay, so alter table. What is your table name? What you want to do? You want to alter, you want to drop, or you want to add something. So here my request is to drop. So drop a constraint, and what you want to constraint. What is your constraint name if you remember correctly? But right now we don't have any earlier case you have created something called check ID, right? This is how you can drop it. Okay, this is how simply you can drop it and it will work. Right now, my table doesn't have any constraints, so already I dropped, so there's no need to worry about it. So this is how you can simply drop, which we've been seeing already. Let's go for the next one, how to add a constraint, because my table is as simple as no constraints, no, but I want to add a constraint. So if you want to add a constraint, we need to ensure again the same very stuff you are going to use, that is a alter command. So how you gonna use alter table? Check table, we want to, what you want to do here, you want to add a constraint. So obviously we need to use add, then remove the drop place here. Then you are adding a constraint. What kind of constraint you are adding? That is chid maybe. Okay, then you want to put a condition called check, constraint as a check. Then after check, like if at all if you have any something called condition, just say id greater than or equal to something 100 or whatever it may be. So this is how basically anytime, this is very important guys, the thin line which you need to understand. My table already have constraints, no problem, my database is working fine. What if you join in an organization where the table is created by someone else and it doesn't have any constraint, and somebody asked you to create a constraint? This is how you are going to create. That means after how to create, this is what you are going to do, that is altering the constraints anytime. So when you run this, you should not have any issues. And once I refresh my database, hopefully I should see my table. Let me go to emp sorry constraint table, a constraint database. Under the table, then we have something called check. If you go to a check key column, you should constraint column, you should be finding your chid, which you dropped earlier. Now you created your own constraint by altering the table. So that's how you are going to manage. But if you want to see, uh, maybe let's try to see one more example so that you can understand. I'll use one more one because I've been just working on the ID column. Let's see on how it works on the check constraint. Location gone. Check on location, because we want to use multiple things, multiple values. So let's see underscore one, because there's a one more table altogether again. Let's assume while creating table only, I'm adding a constraint. Okay, there are two ways you understood now. Should not be any question how to add a constraint later, how to add a constraint while creating the table itself. So we have a two uh, types of situations which we are trying to see. Now we want to add further location. Let me put in a separate column so that you can see the entire stuff. Let me increase the font size. All right. So location, what type of constraint you want to see? What kind of check you want to impose a constraint here? Let's see. You want to say constraint, and you want to give some ch underscore loc, because I'm working with the location column, and you want to say the location should be, okay, the location should be in. I want to ensure that it is in Hyderabad. Okay, it should be in Pune only, because I have these two centers only open. So obviously I want to put a constraint. It should be only between this and this. So that means I'm closing one bracket because this bracket is related to your this values, obviously. And I'm closing one more bracket because this bracket is related to your the location before what you started. So you need to ensure that whatever the brackets which are open, braces you open, should be closed. But when you run this, what happens? Okay, there is still an issue because I'm trying to concentrate more on, I just opened a bracket, I closed it. Okay, I opened a bracket, I'm closing it. Everything looks good, but what is missing here? If you look at the initially you started with a bracket which is now way closed. So ensure that you are closing that bracket as well. All right, so this is, sorry, this is how you are going to put a check constraint on the location. If you think you have hundreds of values here, you can just keep putting all the conditions here. If you have something called, let's assume you have a salary column. Okay, we have a salary column. I'm adding one more column because the table is not yet created. You want to check maybe the salary should be greater than equal to or less than. You want to ensure that it is always 20,000 above. No person, no employee should be getting less than 20,000. That's a company norm. So I'm just trying to put it should be 20,000. So this is one type of a constraint what you are trying to put on a salary. This is one constraint what you have seen earlier, like on ID, I'm trying to put a constraint. This is one more constraint which you are trying to put on the location itself. So this is how it is going to work in the real time where you want to put. But again, check has its own demerits. That is, it allows you null values. That's the biggest limitation what we have. But however, we can always avoid that limitation by using a not null combination with the check condition. All right, so default constraint, basically again it's a type of a constraint which will try to ensure you are entering the right information into the table. That means uh, maybe the user has forgot to enter something, but still I want to take some default value there. Okay, you have not entered your age, but I'll ensure I'll think that you are above 18, so I'll give some default number there. So again, it has its own limitations. Whether it's good or not, we need to decide with by using certain examples here. Let's try to see that. So default constraint basically is used is used to provide value for a column. That's it, as simple as that. I'm writing in a simple plain words what the default means. So it is going to ensure that it is going to have some default value. Let me go back to the table. I want to steal my own code again in order to create a default table. So here I'm just putting a default here, and here I want to say default. All right, so right now my table is very plain. It doesn't have any type of a constraints here. You can see the very first column is ID, EMP name, location. Now, what I'm trying to achieve and what point I want to prove here really, what if I put some constraint called default, how the behavior of the table is going to be completely changed. So while creating the table, let's try to see how to add a constraint. So that is for the location, let's see, constraint. I want to say, being it's a location also, so D underscore LOC. Try to give such name so that you can easily identify. Okay, my constraint name is D means default, LOC means location. So something try to give in a such a way so that you can identify. So next you want to say what actually the constraint. Let me put this here. Okay. So what kind of a constraint you are imposing? What is the name of it? And what you are trying to do? That is your nothing but your constraint. So after default, you can specify anything here. Can I see Pune here, something like that? What does it mean? That means you want to ensure only Pune is inserted in the data. Uh, if you're not entering anything, you want to insert only Pune information in the table. So let's see with a practical example. I want to go for inserting data. I will copy all the insert statements at once. I'll put it here. Then, okay, there is a problem here. I need to change all the table names because when you're copying and pasting, ensure that you're giving the right tables. All right, I've given the default, but I want to see what Rekha was referring earlier. Alt F1, what happens? If I put Alt F11, again, it's not giving me any information in the first one, just telling me when database is created, what is the date and time, how many columns you have, whether it is nullable or not. Everything is fine, but what is more interesting and attractive to me is the last section, which is telling me what is constraint, what kind of information he has provided. He said default. What is default? Okay, Pune is the default here. That's how you can easily understand by going to Alt F1. Okay, is it Alt F1? Yep, Alt F1. Yes, Alt F1. So once you use the Alt F1, you'll get the complete history of your table, data types, whether it's nullable or not, what type of constraints they have used. So here I want to see how it works if I don't mention Hyderabad here. Okay, I'm using Hyderabad. I'm trying to insert a data into my table. Okay, one row is inserted. Now, my question is, you told me when you use the default constraint, it will ensure that it will create only Pune. But why Hyderabad is got inserted? Anybody has any question here? Default table. Okay. All right, guys. This has to be clarified. If you talk about 100 examples, make no sense. You need to get the logic here. My constraint was only Pune. But when I'm inserting 100 Deepti Hyderabad, why it is taking that information? Is that the way it should work or some other way?
Default will, I guess, default will work in case of like missing a lot of the null values.
Excellent. So that means it will not tell you anything whenever you are inserting any data. Let me insert this also. Okay. Let me insert this also. Okay. Let me insert properly Pune because that's what is the default value, Pune. So when I try to run this, this is also running. Is this works? Yes, this is also working. That means it's also accept null values. Location should be, let me run once again. It's taking. Let me run once again. It's taking. That means it is working, but the condition it should check is Pune. Check constraint is different. Default is different. Check will check while you are putting information into the database. Default is something, if you miss the value in that particular column, I will take it granted you are from Pune. That is what it is saying. All right. So let's try to see the actual message which you want to pass. So as you know, if you want to give only restricted columns, let's say this is 100, this is, okay, this is Monty, and here we have nothing. This is what I want to see. But when you run it, you will get into errors. We know why. Okay. The reason is we are getting here, we already know because the number of columns I'm not really satisfying. So we need to ensure that we are giving the proper column names. That is ID, then use EMP name, just close the bracket. So what does it mean? I want to insert only two column values here. Just I run this, happily it got the information there. So let me run this, where this 100 Monty and what exactly the location is all about. If you see, Pune is the default. So default, guys, there's a lot of thin line difference between uh, Pune, sorry, that's a default and a check constraint. Check constraint, while you are entering the information, it will check whether it's a correct or not. Then it, before actually it goes into the database only, it will try to check, it will throw an error. Whereas the default, irrespective of anything, you keep entering the information, it will take everything. But only when you miss the value, something like in the last example, then it will try to go with the default information if it is not working. Hope you guys understood what exactly the default constraint.
Yes, sir.
All right, so let's try to go back to the same very old story. How to, what if a constraint is already there or not there? How to create that? Okay, the problem is here again. All right, just let me write here. What are the constraints we have seen so far? Not null. Then we have seen check constraint. We have seen default constraint, not null. Then we have something called unique. The next important one, that is a primary key, and this is a foreign key. All right, so we have seen almost, we covered everything apart from these two. These two, we put it for the last because these two has to seen at the combination only. We cannot learn individually. We have to understand them very clearly at combination. So before we actually get into the in action, we'll see what are those, what is the advantage, what are the limitations for that, how these two keys are really going to help me when I'm creating a table. All right. So for that, let me just grab my comments here and as well as creating a table. Let's create our own table this time. Okay. The primary key. Okay. The name of the constraint is primary key. And what exactly I can do with this is it is used to uniquely identify data in the table. Okay, I'm trying to understand now. Primary key is basically used in order to identify data uniquely. Okay, what is next? It can't have be null. Okay, so next should be unique rows in the table. Next, it should be only one primary key is allowed in a table. So these are the golden rules which we are trying to follow, and we'll also see in action, does it really make sense? It's a combination of unique and not null constraint. So these are the primary features of this particular primary case. It is used to uniquely identify the data in the table. It cannot be null. So that means uh, if I go back to the very first constraint that is not null, uh, whenever I'm trying to put this constraint called not null, it is not allowing me to enter a null values. It is ensuring that you have to enter something. But here, even if you don't use what you call not null, the primary key itself. Okay, this is one more constraint which we'll see in action. But try to visualize this. When you use a primary constraint, by default, it will not allow nulls in the column or any particular columns. So next, it will try to identify every row in the uniqueness in the table. And the beauty of this particular primary key is we can have only one primary key in the table. And it is a combination of unique and not null constraint. Then we need to talk about a foreign key. The reason is they always go side by side. If you learn only primary key, it doesn't make any sense because we need to have a foreign key. Again, let me make it more simple. Primary key can also be termed as a parent key. Okay, okay. It is a parent, and when I talk about your foreign key, it is a child table. Okay, child key, it is a primary key. Let's try to put this way. This is your parent, this is your child. We'll go with a lot of explanation on this because this has to be understood very clearly, because most important uh, question being asked in the interviews. Okay, this is a foreign key which is called as a child, and this is your master or simply a parent. Now let us see what are the features we have in the foreign key. So how exactly the behavior of the foreign key will be there when I'm start using and taking the advantage of this foreign key. So it is basically used to maintain ship between two tables. Guys, let us not have any confusion here. What is the relationship here? Relation, when we talk about a relation doesn't mean that we are talking about a joins here. I want to maintain a relationship between the parent and child. So when I talk about a child, uh, one child can have many parents. No, it's not possible, right? So one parent can have multiple children. So that means one table will have a primary key, under that we have multiple tables with a foreign key. Now why we are trying to have this kind of a combination? Because we want to maintain a relationship. Okay, that's the first. Let me put down all the points so that we can have more discussion on it. Can accept the null values, though it looks like a limitation, but you'll see going forward while you're doing in action what is the advantage of this having a null values in the table. It can contain duplicate values. Okay, more than one keys are allowed in a table. It can contain duplicate values. Oh, there is a lot of difference between the foreign key and primary key. But the primary difference you need to understand, the primary key is a parent key and the foreign key is a child key. Okay, let us look at the first one. It is uniquely identifies the table. But if I try to compare with the foreign key, it is not telling that I'm going to maintain the uniqueness. It failed. It's saying that it can contain the duplicate values. It can contain the duplicate rows as well. It can contain the duplicate rows, but here in this case, we cannot have. We are trying to have a relationship between primary table and the foreign key table so that we can maintain the right information. Let's assume a practical example, maybe a store or a student kind of a university information or a student school database or employee table. Take any example. Let's try to take a store which is more closer to us. If you go to a supermarket, you will have one primary table. Okay, we can't see physically. I'm just giving a visualization here. We have one table called customer table. Okay, there is some other table called product table. Let's assume in the primary table, you will have all those customers who are frequently or regularly visiting these stores. So let's assume we have 100 customers. So the primary table will ensure that these 100 customers are not keep getting repeated in the table. So that means we have 1 to 100 customers. So whenever he is doing a transaction, the data will not be stored in the primary table. Rather, it will store in the child table. So how this primary table and child table is connected with one unique key. Okay, you should have one kind of unique column which can they talk to each other. So let me put more specific here. I'll use it to open Excel. Okay, we have a primary table here. Let's take, this is your primary. All right, so let's go for the child table. Okay, when I say primary table, it is nothing but the primary key. When I say child table, nothing but your foreign key. So here, let's take a hypothetical situation store example. I have something called ID column because I'm a customer there. I have a name column. I have, let's say, I have a location column. Okay, and this is my primary table. And in the child table, probably I have something called related to a product. So product name. Uh, uh, Amount, maybe we have ID. All right. So if you look at both the tables, it can have number of columns. Doesn't matter how many columns we have. Is it we have here 100 columns, here we have 50 columns. Doesn't matter. But in these two tables, there should be one column which is the same, not in terms of the column name. I mean, it could be a something called CST ID also. But what I'm trying to make a point very clear here, both the tables should have one unique column, one column which has the same kind of a values, because that's the whole object here. Because whenever a customer is reaching for the first time, the information will be stored here. Whatever the transactions he's doing, it will be stored in this particular table. So that means ID, let's assume we have a ID called 1 and the name is Monty and the location is HYD. And let's go for the child table. Child table is, let's assume product name is something called uh, anything like TV, and we have amount called 1000 and the customer ID is 1. Okay, so this is one transaction what this Monty has done. Let us go for the next transaction. What it is doing is doing something else, XYZ, then it is something called 2000 and this is 2. Now, if I try to compare this table and this table, I can say this one is my customer who has done a transaction called TV, purchased a TV with a cost of 1000 and he has ID as 1. But who is this guy who has done a transaction called XYZ whose price is 2002? Is this 2 existing in the primary table? No. So that means he's not a valid customer. First of all, your child table will never allow any number or any ID which is not existing in the primary table. As simple as that. So that means this, let me prove the point again. This guy is trying to do one more transaction. Let me put this way, 1000 and here is the ID is 1. He purchased a product called A and this is 2 is 1. This is B, he has done 3000 and it's 1. Is C, he has done one more transaction 2. Now let's have a very interesting, healthy discussion here. There is a customer called Monty, which is in the primary table. Likewise, we have some hundreds of customers, let's assume. This guy, he's doing a transaction. It's not like once he goes to the store, it's over. He keep going, right? So he went to the store, he purchased a TV, which is cost is this, and his ID is this. Again, he is this time he is purchasing a product called A and this price is this and his ID is 1. So these two products, if I want to search my table, what Monty actually purchased, I can simply select this information and also the information from these tables so that I can get the complete information. Okay, so here you can see the one is getting repeated and again. The reason is he's keep visiting to the store to purchase something. So that means my foreign key can have a duplicate value. So that means what is duplicate values here? 1111, which is repeated, which is a duplicate values. But can I have one more one here? No. With something called Ronnie, no, I can't have, because primary key says like it will use uniquely identifies a data in the table. Uniquely identifies. Next person I can have 2. So next time, second person in the next month, maybe he purchased something called XYZ products with some 100 and his number is 2, which makes really sense. But if I say something called ABC as a product, and if I say some number and 3, which doesn't make sense, because it will always, the child table always try to check in the primary table, is this ID existing? Okay, I'm just writing here, but actually it will never allow the third row. Third row in the sense, uh, you can have this kind of transactions as many as, because this number what you have written at the right, which is a customer ID, here it is called as ID. Doesn't matter. The column name can't be the same. Doesn't matter. It can be same. That is also okay. Even if it is different, we need to ensure the column values are same. Okay, so coming to the point, here I have a 3 ones because my child table will allow duplicate values, but my primary table will not allow duplicate values. It has only one repeated once. No scope for the second one. So the primary table will try to maintain the complete customers of the that store, complete employee numbers of that company, complete student IDs of that particular uh, school. Okay, let's take this as a school. Let's convert to this school. Okay, there is a school in which we have a 2 students. Okay, this is, let's say this is again, of course, Hyderabad. There are 2 students, 1 and 2 roll number. And in the month of January, they paid a fee and his ID is this. And this first guy again paid the fees in the month of February, in the month of June or whatever, and he paid the fees in the month of January. He paid it a single go, that is by Ronnie. But if you look at the third one, which is a wrong information, because there is no such student existing in the primary table, and you are trying to insert a row which is not feasible. That's the kind of a constraint which you are trying to bring by using this primary and foreign key here. Okay, the golden rules we need to remember: both the tables should have one column same. I don't mean column name same in the sense, if a primary table is having ID, foreign key should also have a ID. It could be different, doesn't matter. But as long as the column names or say column values are same, it's fine. So primary key cannot be null because primary key advantage is it will also ensure that it cannot be null, and it should be uniquely identified. Yes, of course, the primary table should have only a unique case, because if you have 100 customers, if you have 100 students, only 100 students forever. These 100 students might be paying fees in every month. So that means, just imagine in your child table, 100 into 100. So that means they are doing that many type of transaction, not transactions, but whenever they're paying fee, a newly recorded new record will be inserted into the uh, child table. So this child table will keep growing with multiple duplicate values, and it should have actually, if you look at practically, because Monty is a customer who is keep visiting a store and is doing lot of transactions. So all these transactions are getting stored in a second table that is called as a child table. You can have multiple child tables, doesn't matter. Okay. And this guy is also done transaction, but very less, only one time he has done, but he can do as many as he want. But the third person is invalid because it's not existing. Had it been a new customer is added here, ABC, whose location is Hyderabad again, you are allowed to have anything for that matter, X some 200, and we can have that ID here. Now if you see, all these ones are related to Monty here, all these two are related to Ronnie, or three is related to ABC. Now if at all tomorrow, if I want to analyze this ID, a person called Monty from Hyderabad, how many transactions he has done, I can clearly see by getting the information from the both the tables. So it's quite easy. You are trying to maintain the relationship. It will never allow a duplicate values in the primary key, but here it will allow the duplicate values. That is the whole essence of this table here. Okay, so I just created a table for our primary table, primary key to in order to see the primary key example. So I created a very quick two columns. One is student name and the ID. ID, the ID name can be different, like STD ID or something like simple ID. Okay, I want to have ID only because I want to create one more column with a different column name in the foreign key, so that we can really see, is it really works even if the column name is different, does it really works or not, we want to check. So once I given this, how you start a constraint, we always use a constraint and constraint name. Let's see, primary key, that's how it works. It's not a single word. Okay, it's not a single word. Primary key, once you use a primary key, then what you want to do here, okay, what you want to do, already you mentioned primary key, that's fine, that's it. So that means this table is now has a primary key. Now I created primary key. I can also see where the primary key is going to look like, how it's going to look like. But before that, I need to know what are the rules here. It is used to identify uniquely table. It cannot be null. It should be uniquely identified. Only one primary key is allowed. It is not. It is a combination of unique and not null. Very good. So these are the points you need to keep in the mind before you actually run this table. So let me just run this table and see if the table is created. Perfect. Now let me go back to my database and simply run it. Once you say refresh, if I go to tables, if I see, where is primary table? Okay, student table. Once you go to student table, when I look at the columns, you'll see some kind of a golden key here. Okay, key. You can see a key here, golden key, and it says not primary key, but in fact it says like PK. PK stands for primary key, FK stands for foreign key. That's how it denotes in the system. Doesn't matter how it specifies. If you go to the keys, you can see a different name. Why different name? Because you are not interested to give your own name, so it has taken its own name. That is PK underscore student underscore. It's very big, lengthy name. Doesn't matter how lengthy it is, but we always can copy, Control C, and put it here. Okay, but it looks really odd. Try to have your own names. You can say before this primary key, constraint, constraint name, primary key. That's how you can spell out, which you have seen in the previous case. Now that we already have a primary key in place, I want to see how to insert a data into this. Let me quickly insert the data into this. What's the command? Insert into student student table. Then I want to go for a values. So let me go for the values here, the one DP, and that's it. We have two columns here. So this is a string. We need to put it in the this. So can I have multiple columns insertion in the same time? Yes, we can. Let's go for the second name. That is okay. And then we have the third column. Let's say 3 comma. Then we have something called uh, within the single quotes Monty. All right, so I'm trying to insert all three rows at once. Hope you agree, because I don't want to create three different insert lines. This is a simple way of inserting data into your table. Now I have two columns only. I'm trying to insert two values. So let me quickly run this F5. No surprise, it will create all the information perfectly because you are really providing the information in a proper way. So let me try to select data from this table and see what is happening here. We have three rows, 1, 2, 3, Deepti, Kavita, and Monty. So the three people who got already data into table. So what is happening here? What I'm trying to prove here, you said like primary key is maintains a unique records. Of course, it's maintaining the unique records. If you see, all are unique. What if I insert a data which is not, which is already repeated? Maybe let's see. Let me insert a data here. Insert data into table. Then I want to say same one. Then I want to put any name for that matter. Let's say Ronnie. Then close it. So will it allow? That's a question. Will it work or not? Okay, I'm trying to see if the constraint has this kind of features, if will it allow me to run this query on this particular table. Okay, I got a pretty straightforward error saying that you cannot insert this because there is certain kind of a constraint which is really working on this, and the constraint name is pk underscore student. As I said, pk stands for primary key, cannot insert a duplicate. That means, let me go back to my theory to refresh my memory. It is used to uniquely identify data. Excellent. That means it is started working, right? So it is not allowing me to enter any data which is already repeated. So this is not working actually. It's I just written working, but it's not working. So let's see the next example with blanks maybe. I want to use a null value here, but I want to go back to the story again. It can't be null. Okay, let me see. How far is true? Primary key really working on the nulls also? Yes, excellent. Cannot insert the value null into the column ID table constraint because this is a table. Column does not allow nulls. So it's not allowing me null. That's a basic primary advantage of using a primary key. It's not allowing me null. It's not allowing even the duplicate rows. Let's try to go back to 3 area again. Should be unique. Already we are trying to maintain only one primary key. Is that true? Let me drop the quickly this table because if I want to experiment, I want to drop the table student. I'm dropping it. What I want to do is this time I want to create a primary key on two columns. Let's do that. Okay, I have two primary keys now for what do you call? We have for the name at the same time, student name for the at the same time for the ID. When I run this, it's going to give cannot add multiple primary keys constraint into a table. So this is a clear indication, guys. That means what it's uh, what it keeps saying and exactly it is trying to implement, right? So it said you cannot have multiple primary keys, and it's clearly telling this is an error if you start using. So let me remove, which is not a fair job to use a primary multiple primary keys on your table. So before that, let me create the table again, and I want to insert the data again. And I've seen the first example, it was not working because it has a duplicate row. Second example, it was again a null, it's not allowing. So practically we have seen how this primary key is working so that we can see while building the relationship with the foreign key, which is going to play a very important role now. So far we have seen just primary key, how it works. And it is a combination of unique and not null. Is that true? Anybody can comment on this. Is that true? Is it maintaining the uniqueness and as well as the not null constraint features?
Yes.
Right, it's try whatever it said, like it's trying to prove the point, like it is also maintaining the uniqueness, it is also maintaining the uh, what do you call uniqueness and not null constraints here, right? So let's begin with the next one, that is talking about foreign key. Foreign key plays a very important role. You created the primary key, you put certain kind of I mean, constraint called primary key, and it's acting so well. My table is very neat. As I said, like here, this example, I keep creating the customers list here, but as you could see, it is not allowing me any customer with a blank IDs. It's trying to ensure that you have an ID there. That's so that you can uniquely identify each row. Okay, uniquely identify each row. Monty and Monty is repeated, no problem, but they are uniquely identified with a ID number here. And you cannot have two and two again. That is what the primary key says. You cannot have multiple numbers here. I mean, you cannot have a duplicate. You cannot have a blanks. That's what we are trying to see here. Let's see how the foreign key works here. Uh, Table with foreign. Okay, so let's go back to the history here. What a foreign key, which is also called as a child table. It is used to maintain the relationship between the two tables. So primarily, when you create a table with a primary key, it makes no sense actually. It works as simple as any other constraint like not null, unique. It works individually without any different behavior. But when the primary key is associated with the foreign key table, then you'll see a fantastic change in your the way they behave the tables. That's the whole essence of having this primary and foreign key here. That is a parent and child relation. I keep telling like parent can have multiple children, but multiple children can not have a multiple parents, right? So that's how it's going to work. Now let's see how table with foreign key really works. So for that, again, let me steal my own code to see how it works. We have a student already. So what should be the, let's say course as a table. Okay, one is your table, and this is instead of saying ID, let's give a different column name, but still it's an ID, guys. So let me remove the primary key, and we have student. We doesn't require because student name is already referred here. So we have student name, we have student ID, we have a student name. So what you want to bring here, we have a student ID. Then you want to say course maybe as a varchar, something like 10 digits, and then we, yeah, let's say this example. That's it. That's enough. Now, if I run this, it will obviously it will create a table, but I don't want to create. I want to create a foreign key on this and see how exactly it make a difference. Let add one more column so that it can be more visible. Actually, location maybe varchar 10 something. So we have totally three columns, guys. Here I have three columns, or something like we have ID, we have what course you are looking for, and we have something called location as well. So this is my second table. Okay, let's not say this is a course table. Let's see practically here. This is my student table. This is primary key table. This is a foreign key table. And here we go. We have these informations right now. And the column names are follows like ID. We have student name. That's it. So we have two columns only in the primary table. And let's see what are the columns we have in the course. We have STD ID, and we have yes, course and location. So these are the two different columns what we have here. And here we have some different columns. Now let's see practically how it works. Hope you're understanding what exactly I'm trying to design here. This is two columns which are related to this primary table. These three columns which are related to child table. That's what I just created here. So now when I come to this one, let me bring it on to the next line so that you can see. Yeah. So we have a STD. Let me STD ID. Okay, so that it makes sense. Student ID, integer, course, which course is opting for, and what is the location, which where is exactly staying. Okay, so let's try to insert a data, but before that we need to have a table in place, right? So how do I create a foreign key on student ID? Okay, either you can create the same something like the primary key what you're creating, you can create the foreign key here itself, but let's try to see other way around of doing it. You can also put all the constraints at the end of your creation of table, which will be easy for us to read also. If you put here, it looks as if like it looks entirely a column name like. Okay, if you put at the end, you can really differentiate what keys, what constraints are applied for which columns. So I'm just trying to show a different model. Otherwise, you can still go with the beside int only. You can, I mean, beside the student ID only, you can put the constraint name. Let's try to be more specific here how it works related to ID for this course table. So here what I want to do is I just want to use a comma separator because I'm writing some constraint here. Now what I want to do is for which one, that is stdid, that is a column, I want to use the int type, which is already there, right? So we have already have an int. So let me make use of it. Let me make use of this. So here I want to say foreign key, just like the way you have written primary key. Now the question is how you are going to build a relationship between the primary and the foreign key table. Now, we know that there is a table called student table. We know that there is a table called course table, but they doesn't really are together when it comes to, they're not really together when it comes to connection, right? It doesn't connected right now. It has a column called ID, it has a std ID. So how they are connected, we need to see. Now foreign key, then we need to use reference as a keyword. Okay, reference as a keyword. Now you need to tell to the table very explicitly what reference you are taking. That is student table. That is my above table. What is my above table? Nothing but my parent table. I repeat again. For this std ID, you are trying to build a relationship with this table. That is a primary table. The constant name is a foreign key and a reference I'm taking which table, because in reality you might have some hundreds of tables, right? So which table you're talking about. So right now I have a two tables, so it's quite easy. The course table is trying to talk to a student table here, so I said student table here. After student table, you need to be very explicit in mentioning that which column you are referring to, that is which column actually you're looking for in order to make this relationship. So what is my primary key tables parent table column, which is a primary, that is ID. That's it. Sorry, no need to close. Guys, is it clear? So first I'm trying to create the primary, first always you need to remember you need to create the primary table. Once the primary table is set up, is already over, then you need to create the second table called the foreign key table or child table, where you are not just creating something like a primary key, we are telling something else. That is your key is foreign key and you are taking the reference from which table, because you have multiple tables in your database. Under that reference, which table you are talking about, under the table, which column you are talking about, because my primary table consists of ID column and my foreign key is having a std ID column. That's it. This is how you are going to talk to your tables. Now, once I just run this query, you should be seeing, okay, number of reference column is foreign key differs from the number of referred columns, table, course table. What is the problem? Do we have that student table actually? Let me use a select star from you. It's showing some error. So that means the table is either existing or dropped. I don't know. So let me try to run this. We have the table. Yeah. Let me see. Create a table. Course table. Course table is your new table, which is formed for to create the child table. std ID is your column name, and foreign key, which is a reference of. I'm missing something. No. But this should not be a case actually. It should be last. No. It's saying foreign key reference invalid student table. Why? Column name is ID only. Oh,
Shravan, can we? I think we need to put foreign key before the comma. Student ID int space foreign key. I think.
God. This is creating a problem, guys. We are giving a separator. Why we are giving a separator? We'll never have a separator after your constraint. For example, here, I've never used a comma here. Maybe misspelled here. So we are not supposed to have this comma separator. You're right. So I'm creating this table now. Let's see if you get the table. Yes, command successfully operated. Now, more interesting is if I go to Object Explorer, what I'm interested to see. This is what you need to understand here. I'll show you the injection into the tables, how the data goes. Let me go to the tables, and the table we have is student, which column is primary key. If you go to the foreign table, where is course table? Yeah, in the course table, if you go for this calls, both are keys. Somebody is grayed out, someone is showing with golden color. It's a golden key. This is a gray out color. So it is FK. This is PK. That means primary key and foreign key. Now there is a relation between these two guys. There is a relation between these two guys. Now, before we actually get into more discussion, I want to see what is there in my table. There are three rows with three IDs and three names, right? If I start inserting a data into my second table, how the behavior is going to be, let's see. So for that, I need to have some insert command. Let me just copy this. So insert, we want to insert into which table? That is a course table. And what are the values you want to insert? So one, I want to insert something called some name, and the location, we have the location column. So no, sorry. So we have the first course name. Let's say a course name is Excel. Then we have the which column, that is location. Let's say Hyderabad here. Then we have something called ID. So ID is one. Now, my question is, will this insert into a database? Now, having understood the conceptual information, there's no need to say multiple examples here. We got the concept, very basics are strong. If you can answer this pretty straightforward question, is it a right information to store in the database?
Yes.
Okay, let me insert quickly. Okay, it's taking. Let me put both the tables here so that we can keep comparing and see practically what is happening. Course is the table. Now running both the queries at once. So if you see, one is a student ID whose name is Deepthi. Deepthi is interested in Excel course and she's from Hyderabad, and student 8 is one. What do you think? Deepthi will be only interested in Excel? She also might be interested in SQL. That means the second table can have a multiple rows now. Yes or no? But the primary table, Deepthi will be forever only one time, and her identification is always with one. But the second table, our identification being one, can have a duplicate numbers. That means second time the student ID can be one again. Our location can be same or different, because our location is, she changed her location, doesn't matter. The location can be different, but the course also can be different, can't be same. Let's try to insert one more data here. I'm using the same data again intentionally to see how it works. SQL this time she is interested in. When I'm running, this is what happened. Now let me run both the queries. Now you can see one person from the primary table. We have three set of students in this course. In this institution, let's assume three set of students. Under this three set of institution, so far only one person who has registered for two courses, that is Excel and SQL. So that means the second table can have a duplicate rows. It will allow duplicate. This is a duplicate itself, right? So one is a duplicate row. So that's what the foreign key. It can contain a duplicate values. She may have the same course again in her life. Let's try to see that if it's possible or not. Oh, that means she can get the Excel course again and again. That doesn't matter. Yes or no? She can also get the SQL course again and again. Doesn't matter. She re-registered again for the course. So you can see that one is being repeated, and location is Hyderabad. Excel is repeated. Hyderabad is repeated. SQL is repeated. There is a lot of stuff which is duplicated, and nothing wrong in this data, which is quite obvious. Actually, we can have it, right? So let me truncate now. For now, truncate course table to see practically some more example. All right, so my table is truncated. I'm just inserting one row for now and second row for now. So in order to see the clean data, okay. So now we have one ID, a person who is opted for the two courses. Now let's see The actual inserting of data, if I say two in the foreign key table, I'm trying to insert a data with an ID called 2. He's interested for the course called Python. Let's see what happens here. Inserted data into your course table. Let's see what happens when you're trying to run this. Now 2, is it existing in your primary? 2 is, who is 2? 2 is Kavita. So there's nothing wrong. She opted for Python. So 2 is existing, 2 is existing. Let's go for one more interesting task here. I'm inserting 5 who is interested for Python course. Let me insert this. What's this? The insert statement conflicts with the foreign key constraint. The foreign key name is this. The conflict occurred in the database. Why? Why it is occurred here? Why you're throwing an error? Why you're not happy? Because the ID column is trying to talk to each other. Because if you look at the primary key doesn't have, the primary table doesn't have a number called 5 and you're trying to create a course for her. So you should must and have a record in the primary table. Then only you are eligible to have multiple records here or eligible to have multiple uh, courses to offer. So I'll take a quick pause here before I go further because I have few more examples to talk about that, but I want understanding is correct or not. Okay, let me go for this blank value. There is a golden rule which in the foreign key says it can contain duplicate values, of course proved. More than one foreign key can allowed in the table. Maybe you want to create one more foreign key here so that you can talk to another table, which is possible. Uh, it can contain a duplicate values. Okay, it can contain null values. How it is possible? Let's try to see that. So here in the ID column, let's see a null here and try to run this. You are talking about the second table, right? That is a, now when I run this, it can have null. But is there is a null in this primary table? Why it is allowing me null? Because null is a missing value. Anytime you will update this number with something which is there in the primary table. What if this null is been trying to be get updated with some number which is not existing in the primary table, will it allow? So that means this Python course brought from a person who is from Hyderabad. Uh, his ID is 5. Is it a right statement?
No.
Why? Why? Because that ID itself is not existing in the primary table. So that means he's not an authorized person, in fact.
Why is it allowing null value? Because as you mentioned, primary key cannot be null, right?
No. 1 second. Hold on. I'll come to the question again. This second table is talking about a child table, nothing but your foreign key. This is a primary key. Foreign key can have what? It can accept null values. So it's accepting the null values. This will not accept the null values, which you have seen practically here. If I'm using a null values in the primary key, it's not working. It's not really allowing me. So when I try to insert, it'll throw an error. Okay, it will not allow me to, not sorry, this one. It will not allow me to enter the null values because the primary key advantage is it is always say I want to identify uniquely. You cannot allow me nulls also. It can't be null. Primary key. I'm talking about primary key. That is a primary table. Foreign key. It will allows the null value. That is what we are trying to see practically here. When I'm writing this, you got a null. So my question here is, if this null is being updated tomorrow, let's try to update and see practically. Okay. Update course table. How should I use a statement here? Set. I cannot use, the problem is I don't have anything unique. Okay, set stdid equal to 5 where course name equal to Python. Let's see if it works. It should work. How many say it works? Will it work? I'm trying to update my course table, nothing but the child table with 5 because the behavior of the foreign key is it will allow nulls. It is really allowing. But tomorrow I want to update with some number. So let me update this.
But it may change 2 rows.
That's okay. Let it change. But is it working or not? That's a question here. So, okay. So let me try to put something else then. Insert a data with C language and it's null. Okay. Let me insert one more row here. So before that, I want to see it's running. Okay. Now we have 2 nulls here. Now the question is, it's allowing null. That's a behavior. if I want to update this null, whose language is C language, with some number, let's see what is the error we are going to get. Hope you're understanding this C language. Okay, the row 5 C language. I want to update student ID with some number. With what number? 5. So what is the error I'm going to get? It will definitely say the foreign key is working on this, and primary key doesn't have that column ID itself, and how you're going to update this. So it's going to give an error. What if I say like 1 or 2 or something? Yes, it will allow, because 1 is already existing in the primary key. So it should allow you. When I try to run these two tables, you can see that one null value has been changed to 1. So anything IDs which are existing in the primary key, only those keys are allowed in this. That's a primary, that's a thumb rule here. It can have as many as rows, doesn't matter. One, you can see it's repeated thrice. It can also have nulls, but it cannot have such number which is not existing in the primary table. All right, guys. So I'm in hurry. I want to drop both the tables so that I can create a fresh tables and show you how deletion works. That means if primary table is a row is deleted, how the other table data should also be automatically deleted. That's what I want to prove the point, but I'm in hurry and I want to drop a table. So I want to understand what's the error I'm getting. So if you can see, could not drop object student table because it is referred by a foreign key. What does it mean actually? Does it make any sense why I'm not able to drop?
It says
Because
that
the keys are
you
referencing
have,
to each other.
yeah, I mean, it says that there are few records which are left in the other table which are dependent on this, so you can't delete that.
Excellent explanation. So does that mean I will never in my life can drop these tables then? Do I need
Unless
to
you
break
can,
the...
no, unless you go there and delete these reference records there, you can delete this.
Okay, if that is the case, let me see if I can drop the foreign key table in that case, because I don't want to get into that kind of messy world, dropping the exact records, truncating the tables, then dropping the table. That's a long story, right? Let me try to find the easy way. Can I drop, can I drop the table which is of my foreign key table? If I drop this, will it drop? Yes, definitely. If I drop the primary table now, will it allow me to draw? Yes, it's allowing me. So what does it mean? The primary key table is having certain rows. Foreign key table is also having rows. It's not about having rows or not. Even if it is blank, still it will not allow you to drop the parent table. Child has to get dropped first, then only parent can will exit. Concept is clear?
Yes, sir.
First, only parent has to be child has to exit first, because child is depend on his parent, right? He has a relationship with one some unique column. So you need to break that relationship between the parent and child. We need to break it, then only you can break that parent table also. So that's a simple logic how it works. Hope we got the concept here, how it really works. Now let's see, you can use again alter command to add your foreign key and primary key. That's we have seen with the previous cases. Let's try to create a quick table with in order to prove the point, like how the deletion works. Create a table. What is the table name? Let's take student underscore table underscore new, something like that. Then I want to use ID column here, ID as int, comma, then I want to use what was the previous one, s name as a student name, then varchar as 20. So simple, very quick one to understand the logic. So this is my table. Let me use the second table as well. What is your second table? Is your course table, COURSC table. This is new one. So here I don't have ID. Let's say what you have in this course, that is the course name, that is varchar, and we have size as a 10. Then we have something called maybe let's take the location as varchar 20. What else we need? We need some ID, right? So let's use this time same numbers. Okay, same column names. Will it really affects or not? We can understand. Yeah. So we have two columns. Let me close this so that we can have more room to see this. We have primary table. Let me write a parent table. This is my student. What is that? Child table. Child table. So this is child table. No, what's this? Is it right spelling? Child. Create course table underscore new, and we have a course name, and we have a location, and we have a ID. This time intentionally I've taken ID at same tab because I want to prove the point. If the column name seems also doesn't matter, if it is different also doesn't matter, which you already seen in the previous case. So I have the two tables, but completely plain. It doesn't have talking about any constraints here. So first I want to implement the primary key in this case. So let's say primary key. You know how to give the constraint names. I'm not giving for now. Constraint, then use the name, whatever the name you want, then space, then it will create a new constraint name for you. I just want to have a full screen here. So for that, I've given the primary key. So let's go for the int. After this, I used a comma here. Last time I did a mistake, so let's not do the same again. So this time what I'm trying to do is reference. Okay, foreign key reference I want to give. So what is the model of giving a foreign key reference? Let me write it again so that we can understand. First, I want to say foreign, okay, key. Then what you're doing, you want a reference. You want a reference from where? You want a reference from the table called this. Okay. But for which column? The column which is sitting in the primary table, that is the ID column. Now it's quite clear. You can see here. That's why I've created a short tables. I have an ID column from a table called student. That student table ID column, I'm referring as a reference here for the ID column of the child table. That's it, as simple as that. Now, these both tables are talking to each other. Whatever the primary table is going to have, must and should have in the child table. Is it a right statement to say? Must and should have in the second table also. What if my table is having 1, 2, 3, 4, if my student table is having 1 and 2. So what you said like must and should have. So that means, do I need to have, if I have 4 records here, do I need to have 4 records in the second table also? Can somebody comment?
No, not required.
Not required, right? Can I have only 2 records which are related to primary?
Yes.
Can I have some number like 5? Is it right statement to use?
No.
No. Excellent. So we are on the page now. So now that we have a 2 tables which are created, which is clearly demonstrating you how to create a primary key and a foreign key. So let's try to create both the tables at once or separately, doesn't matter. Let me create this one. Primary table is created. Your second table is also created. So that means we have a 2 tables now. Let's try to insert data into this. Let's try to insert a data into this through which we'll understand how this really works. But one important thing which I forgot, that is delete statement. So let me drop this table. Drop. Can I drop student underscore table new first? Can I drop this? First of all, it's an unknown object because this table is not yet created, it seems. You cannot drop because we need to drop this table first. Then you can drop the second table later. So drop. Why you are not able to drop? Because this table is not yet created. Let's try to run this both. This is already existing. What is existing already? Student. But if I try to run this one, it will throw an error because it's already leave it. So let's go back and check on the refresh of your constraint. On the refresh in the tables, if you see student table new is existing and course table is also existing. So I need to first drop course table. When you have child, what happened? Let me delete in the interest of time. Don't want to take. I have a student table also. Delete, delete. So we have 2 tables of created. There is nothing to be dropped or redesigned. So let's try to just create the table of the first primary key, which is just created now for the first time with having a called ID with the primary key. Now, what is the object which I'm really looking for is whenever something is deleted from the student table, it should also be deleted from the course table. But the way I'm saying it's looking good, but there is nowhere mentioned when something is deleted in the primary tables, child table also should get deleted. I have not mentioned anywhere during this query. So you need to mention very clearly that you want this to happen on something like this. So we need to use on keyword after your foreign key reference. You need to say on delete cascade Those who know MS Access, they can put all these constraints through graphical user interface. There is no need to write, but here I'm writing it instead of doing the graphical user. On delete cascade, what I want to do is on delete cascade. So that's it. Like we need to use on delete cascade here so that something is getting deleted from the primary table should also be deleted in the second table. So quite interesting one now. I want to insert data before I actually do anything. So let me take the very first one. Okay. In the single go, I'm trying to insert three values here. ID matching, S name matching. Okay. We have three rows here. Let me just run quickly. Now I need to have this select query here to see what is happening. Select star from this table. Let's see, we have the three data. Okay, now we have the new table is having three rows. Now in the same way, we have to insert the data into the second table also, right? So let's try to insert in the second table. So for that, let me take this information so that I can see practically what's happening. In the second table, there is a course one. Let's try to say the first course is brought by Excel and location is HYD and comma, and what is the other columns we have in this course table? Course and the location and ID, right? So ID is one here. ID is one. So that's it. I'm trying to insert a new row in the second table. So insert into invalid object. We have not yet created the table. So let me run this. Okay, the table is created now. The insert on. Okay, we got the error because we have not inserted the data. So let's try to go for the second table as well. Now select star from the second table. Now, when I run this, both the tables, it looks very neat. If DP is been deleted from this table, related that information should also be deleted automatically because there is some constraint working on this. That is foreign key is already there. And additionally, we have a sub constraint which is working on delete. Please delete. That is what we are trying to say here. So let's try to write one more. That means I'm inserting one more row here. Let me put. Okay, let me put this Excel or something SQL. This time the same person brought Excel also. The next time somebody got SQL, but this guy is from 2. Somebody got Python. His ID is 3. Okay, we have this many rows now. Thus, let's try to run these 3 queries and you should be having the data. Now, when I run this, I have the complete information now. So guys, from here, we need to really concentrate whatever I've done in the same case. We have 1, 2, 3. We have 1, 2, 3 here. We have Deepti, Kavita, Monty. Here we are understanding from the second table what are the courses they opted for this institution. So this is a quite clear, but ideally what the real-time situation should be when somebody is being deleted from the table, the corresponding record should be deleted from your table as well. So let's try to delete any of the row that is ID number 1. So if you want to delete, what is the command? Delete from what table? That is a primary table, because from the primary table you are trying to delete. So what is your primary table name? That is what is that? Student. Where? Why you are putting where condition? Because you want to delete only one particular line of item. So ID equal to or name equal to whatever. So you are deleting, just watch it guys. I'm deleting data from the primary table. This is the first window what it duplicates showing as a primary table. This is a secondary table. I repeat, it should always have a unique information only. That is what we have already seen in action. Second table may not have the unique information because it can have duplicate because one Deepti, second Kavita can brought a number of courses, so it will have more number of rows. It can also have a null values, but that null value in future, if you update, it should be related to this table only, not a different number. So once I'm deleting this, what happens? Now try to, let me try to take a screen capture of this so that we can better comparison. Let me see if I can take the screenshot. Yes. Before deleting, how it looks like, before and after. This is my first table before deleting. Where are you? Yeah. This is my table before actually deleting. Now let me go to the SQL. You are running this data. One row is deleted. It's saying very politely, I've deleted only one row. From which table? From the primary table. But what happened, the reaction about the second table? Let's see. Because I'm not talking about second table anymore. I'm not deleting anything from the second table. I'm just deleting from the first table. When I run this, for my surprise, what will happen is, let's see in action. Let me go to primary table. I don't want to show you in SQL. Rather, let me compare. All right, so let's come back to the Excel again. All right, guys, just check it out. This is before and this is after. Before we had 1, 2, 3. Before we had 1, 2, 3. And after deleting row 1, who is Deepthi, I've deleted completely the record for her from the table. She got removed. Fantastic. But whatever the courses she uh, brought from this institution, also the related information got deleted. You can see only SQL Python 2 and 3 is existing here. If you see 2 and 3 existing, all one records which are related to Deepthi is no more existing. This is a practical demonstration how your delete cascade works. Delete cascade. Now the question arises here, do we really want to delete the information? Whenever you delete something from the primary table, do you really want to delete information from the second? It depends upon your requirement. But there is always an option. Like something happens in the first table, I want the reaction to be happen in the second table also. That's how it works. It's not mandatory. You need to use. There's no such rule. You need to use it. You can also you can delete the data from here, but still you want to keep its related information. If the employee has been resigned from the company, what's the fun having his salary details in the single table? Let's delete. If the employee is removed, his entire salary information also you want to delete. Okay, sometimes may not be. Sometimes if you talk about the store markets, uh, customer information is deleted, but what are the different products he is buying, still you want to keep retain in the second table. Why? That will help you to analyze the purchasing power of the customer. Maybe it will help you to analyze the customer behavior patterns, what not. It will give a lot of insights how actually a customer behaves when he enters into online showroom or offline showroom, what kind of behavior is, like what is more interested in, what kind of products he's looking for. So it could be anything. That's what I'm saying. It all depends upon the requirements. If you want to delete, go for it. If you don't want to delete, yes, we can just avoid that action from here. So let me close this and go back to the SQL, and you can see this is a practical example and why this is working differently because of this reason. Because of this reason. So that's all about all the constraint. What we have learned is from null, then we have seen practically in action and concept wise how the not null works. Then we have seen how the check can also make a difference in when you're trying to create a table, and default is something default. We hardly use it, but there's an option always like to use the default. If somebody is not entering any information, I want to take him granted like he's from finance department. Okay, I want you to select the department, but you are not selecting, right? So I'll take it as you are from finance guy. So that is default. And unique is always try to maintain the uniqueness in the table. And you've seen never talk about primary key separately and foreign key. It's all goes side by side, as you have seen practically in action how they go side by side. So this is a very small topic, but we have taken almost 2 weekends to understand this. Hope you guys understand how this really works.